So let's talk about requirements. If you took my course on becoming a software architect, you already know that an architecture is always based on requirements and that no architecture can be designed before there are well-defined requirements in place. Now, when talking about requirements, we actually talk about two types of requirements. Functional requirements, which define what the system should do, and these are the most common type of requirements, and non-functional requirements that define what the system should deal with, such as load, data volume, SLA, and more. Now, as architects, we are always more interested in the non-functional requirements, as they are the ones that will dictate the architecture. So let's see what are the requirements of this system. And first, the functional requirements. So the functional requirements are quite clear here. We are talking about a web-based system which manages books, inventory, and borrowing, and also manages the customers. In addition, the system should display notifications and also charge annual fee. All this is quite clear. And now, let's talk about the non-functional requirements. Now, usually the customer has no idea what the non-functional requirements are, and it's our job to ask the right questions and get the right data so we can formulate the non-functional requirements. So what should we ask about this system? First, we want to know how many concurrent users should we expect. Concurrent users, or the number of users using the system simultaneously, is important since it hints about the load the system might experience. The higher the number, the higher the load. Next, we want to know how many books will be managed. This data point is important since it indicates what the expected data volume the system should support. If we are talking about millions of books, we have to take that into account when designing our storage. Next, we would like to know how many borrowings are going to happen daily, or in other words, how many actions are going to happen daily. This is important for two reasons. If the number is high, we again need to think about the load. And in addition, since every action is recorded in the database, we should calculate the data volume generated by this number and see if we have any potential problem here. The last question is the SLA. Each system has its own SLA, which defines what is the required uptime of the system. Some military systems or high-traffic commerce sites should never go down, but some are not such mission critical and might suffer the occasional downtime. Of course, no system tolerates downtimes, but some systems are worthless if they have a 30 minutes downtime a year, and for others, it's just a nuance. The higher the SLA, the more robust the system, and the more expensive the hardware. So these are the questions we ask, and now let's look at the answer we've got. So first, the system should expect 10 concurrent users. This number makes sense, since the main users here are the librarians, and there aren't a lot of them in a library. So 10 concurrent librarians sound about right, even a little bit high. Anyway, with 10 concurrent users, we don't expect any load issues, and it looks like we are fine. Next, the number of books is 10,000. This is not a particularly high number, and it looks like we don't need any special considerations for data volume, but we will have to make a more precise calculation to figure out what is the exact data volume. We will do that later in this lecture. The same goes also for the number of borrowings. We expect 500 borrowings a day. It looks like a small number, but we will take a closer look at it. And lastly, the SLA. Now, since the library is open 5 days a week, and on the working hours, we basically need this system 9 hours a day for 5 days, which is an extremely low SLA. We are going to be fine with it. So let's talk about the data volume. First, let's assume one book record is 1 kilobyte of data in the database. This is quite a large record and it's probably more than we will actually need, but better safe than sorry. Now, multiplying this number by 10,000, which is the number of the books in the library, we end up with 10 megabytes as the total storage required for the books, which is extremely low and will not present any problem. Next, let's look at the borrowing record. We assume one such record is about 500 bytes. Since there is not so much data in the borrowing record, it's basically the customer ID, the book ID, and the date of the borrowing, this number looks reasonable. Now, since we're talking about 500 borrowings a day, we will get around 182,000 borrowings a year, which results in 91 megabytes a year. Now note that this calculation assumes 365 days of operation, which is much more than the actual days, since we just said the library works 5 days a week. But again, better safe than sorry. So anyway, we are looking at a typical growth of 91 megabytes a year, which is quite small. So that means we don't need any special considerations regarding the storage. So let's summarize what we have. These are the functional requirements we already discussed. And these are the non-functional requirements we need to consider. So we have 10 concurrent users, 10,000 books, 182,000 borrowing a year. All this translates to 100 megabyte a year, and the SLA is not very important. We need the system operational 9 hours a day, 5 days a week. All in all, quite a relaxed system without any challenges in the non-functional requirements front. So after setting that, let's map these services in the system.